Hello everyone, I am Abdurrahman Al-Huwaikim.
And I'm Brady Fry.
I am Hassan Al-Hamid, and we are Group 13. Imagine yourself at the Valley Library during the busy days of the term, walking through 6 floors looking for a table to sit at to study. And then, unfortunately, you didn't find any. You just has wasted your precious times that you can put into your studies. We are developing a monitoring system that will check the available seats within the library that will be presented on a web page so that students can check the available seats online. In this presentation, we are going to tell you about our unique engineering requirements that we have developed to make a robust monitoring system for the Valley Library. And then we're going to walk you through our functional block diagram, as well as mentioning some concerns we are facing in this project. And finally, we are going to tell you about our future plans to make this project happen.
We developed our unique engineering requirements based on the 5 customer requirements. The first customer requirement is having a monitoring system for seating availability in the Valley Library. Based on that, we came up with the system should monitor the occupancy of the entire area at 70% accuracy and each table at 80% accuracy. And the system will automatically scan the table every 15 minutes to check the availability of the table and update the status. The customer also requested that the system must have an independent power. Considering this matter, we are designing the system to have a safety device to protect its circuitry from current overflow. This will ensure a long lifetime. To save energy, the system must enter low power mode within 30 minutes of the library hours. Another customer requirement is that the system is easily replicated. To satisfy this requirement, we made the following decisions. The system shall incorporate only components that can be purchased from major suppliers to make the replication of the system easier, as well as make the maintainability possible. Also, an admin web page will be provided to add or remove systems. The fourth customer requirement is to have a web page interface. The web page shows the number of available and unavailable tables and their locations to make the navigation time through the library shorter. Furthermore, the web page must refresh within 5 minutes after status change. Finally, the customer requested the product to be easily installed and secure. To accomplish this request, the system enclosure must withstand a 1-meter fall to make sure that the circuitry is safe. Mounting and unmounting the system should take less than 3 minutes to not bother the table users and to cut the maintenance time down.
Looking at our system in a black box diagram, we will only have 1 input and 1 output. The input will be environment N, which is an IR deduction with a wavelength of 12 micron within 5 feet. The output will be the web page, which is going to display the available seats and tables and their location in the library. This is the overall look of the system. Now, let's walk through the individual blocks one by one. The power block will supply 4 volts to the entire system. In case of a need of more or less voltage, a voltage regulator will be used to step up or down the voltage as required. The power block have 3 outputs. The first outputs being power sense, which is the power required by the sensor block, and then we have power com, which is the power going to the communication block. Then we have power micro, which is the power going to the microcontroller block. The sensors block will consist of a passive infrared modules, which will detect the change of infrared radiation emitted by the human body. It will have 2 inputs and 1 output. One of the inputs being the power sense, which we already talked about, and the other one is environment N, which is the IR radiation. The only output is the status. It is an active high or active low signal going to the microcontroller. The microcontroller block, which is the brain of the system, will have 3 inputs and 1 output. An input going from the sensor block, which is an active high or active low signal. The microcontroller block will be powered by the power block and programmed by the code block. The status out will be the output of this block. It's going to contain the new status of the table as well as a unique ID for that table for easy mapping in the online page. The communication block will have 2 inputs and 1 output. An input coming from the microcontroller block containing the status of the table and its unique ID. It will be powered by the power block, and it will send a TCP packet containing the ID and the status of the table to the database. The database block will receive a TCP packet coming from the communication block containing the new status and the unique ID of the table. It will sort the information, store them, and update the web page based on this information. The web page will display the information contained within the database. It will show the available tables and their location within the library. The enclosure will be made from a lightweight, strong material such as aluminum. It will enclose the circuits and only have an opening for the PIR sensor to detect motion.
Within our project, we have hit roadblocks. We've also had concerns as we've moved through the design process. One of the interesting dynamics that we have faced is the different seating arrangements within a library, meaning the library has tables as well as booths and cubicles, and our product needs to account for all 3. Also, each varying tables have power connected to them and also do not have power connected to them. So there's another interesting dynamic that our product has to account for. But we feel that we understand our problem well and are in the design process to create a robust solution for this problem. As far as our steps going forward, we are currently in the process of finishing our final design. After our final design, we will order components and create a working prototype and test that prototype to make sure it acts accordingly as we design it. After we are done verifying the prototype, we will section off a subsection of the library and implement our system there. We will then validate our system by making sure it works in that subset of the library, therefore knowing that it'll work in the entire library. We are excited about this project because it has real-world application. Today we've told you about what we are trying to do and how we are trying to accomplish that in developing the real-time seating availability monitoring system. We also told you about some of the unique engineering requirements that we have come up with as we've designed this solution. We've also talked to you about the block diagram and told you about how those different components are going to interact with themselves and the other components as well as the outside environment. And we've also told you about some of the concerns and roadblocks that some interesting dynamics that we've faced during the design process. And lastly, we've talked to you about the process forward, what we need to do to have a finished product. We thank you for your time.